Okay. So first I'm going to list out the topics I picked, show you a few more examples that we haven't covered yet, and then try to make up some more examples until we run out of time. We are going to have a question from 6. Let's start with the clean board. And by the way, I am going to be working on answering questions on WebAssign and grading your second exam between now and this last day of class, since I'll have some time during that last week. Cool. Topics. Okay, 6.1. What's this? We're going to do an indefinite integral. 6.2. Oh, actually, we're also going to find a particular solution. Like you did on exam 1. 6.2 is going to be a U sub. It's like also 6.2/6.3, a U sub from one of those sections. From 6.4, definite integral. So one of each of these. There's going to be 12 questions total. Question number 4 will be definite integral. Number 5 is the area between two functions. From 6.5. And then we're going to do a question from 6.6. We'll most likely use discs, but just in case I picked one example that has washers. So most probably going to pick one of these, but haven't made up my mind. Okay, 6. Nope, we're done. Do that. Discs. We are going to do a problem by parts from 7.1. So we need to do.
When did y'all find those over?
Today.
For me, it's like
next
Friday. Oh, okay. How about Jeffrey?
He
doesn't have the finals until June.
Fraction decomposition.
Oh, okay.
I'm going to skip 7.4. Partial fraction decomposition. Cool. Then we're going to 7.6 and doing an improper integral. In 9.1, we're just going to find the distance between 2 points. So this will be number 10 on your test, distance between 2 points in 3 space. So we'll do one of these today. Then from 9.2, we're going to find the x, y, z intercepts. That's it. I feel like we didn't have a lot of time to practice chapter 9, so we're going to just keep it simple. So the x-intercept, the y-intercept, the z-intercept, and then that's it for that one. And the last question will be 9.3 about find f of xy given a certain function, like given some actual x and y, like some input. We'll practice these. So starting with questions about discs and washers. Before we go on, any questions or concerns, like anything that you want to let me know at the chat. It's our very last time we meet, so let me know. By the way, even though this is an exam, you can visit office hour next week and ask questions. It's totally fine. Okay, first one. Well, just let's not number these. Find the volume of the solid by rotating about the x-axis. And oh, office hours. Office hours are the same hours Monday, Wednesday, Friday, from 3 to 3:45. Also this Friday too, so I'll be sticking around after class or after classes. Or you can send an email to me. I've been a little behind on checking, but we can schedule an appointment. I'm free mostly all week. Okay. We're going to have y equal to x to the fourth. And y equal to x. And then we're going to evaluate from x equals 0 to x equals 1. So I suggest that you use Desmos to check out what your graphs look like. X to the fourth is a bit flat, but it kind of looks like a parabola. Y equals x is a straight line. We're going from 0 over to 1. We're going to go around. Oops. Okay. We're going to have a hole in the middle, so we want to use washers. So it's like swirl that shape around the x-axis, and you've got this other like straight line here and a hoop here. I'm going to put a washer around that hole in the middle. So we're going to draw what's going on, make sure we know what the outer function is and what the inner function is. Put it into volume. u is equal to the integral from 0 to 1, from x equals 0 to x equals 1 of pi times r squared minus little r squared. Okay, it's capital R. It's the function all the way on the outside. The washer goes around and around, has some width. So you go all the way to the straight line, y equals x. And subtract going to that bend, which is x to the 4th, and then square it. Okay, I don't know if I'm going to do the full problem, but at least let's write the next step and instead of the next volume for a solid. I think you guys would have this afterwards, have the rest of the problem. This x to the multiply and have power 8 dx. I think I'm going to just like leave the rest for you. You should be able to do that. Okay, next one. Find the volume of the solid by rotating about the x-axis and we have, this one's a lot like what was on your test. It's y equal to x over 4. So it's kind of like a question from exam 2. You have x equal to 8, x equals 0, x equals 8, and y equals 0. So I'm probably going to put something very close to this on the final. Again, I would check in Desmos, but you just want to maybe sketch out what's going on. You start at the origin and your slope is positive 1/4. So up 1 over 4, straight line. Going from x equals 0 to x equals 8. And the line y equals 0, which is right here. So you're taking that triangle and rotating it about the x-axis. And we're going to put a disc inside. So disc, a little bit of width. Let's see. I want to double check, but if I remember right, the volume is just the integral. We're going to go from 0 to 8. X equals 0, x equals 8. Of pi times the radius squared, dx. But I'll peek at my notes. And that's the radius of that function. It was y equals x over 4. I'm thinking I can just leave it there. Should be fine for you to continue to work through a problem like this. And if not, just visit office hour. Okay, we're going to go on to doing problems by parts. Integral of x cubed times ln of x dx. So we're going to let u equal ln of x. dv is x cubed dx. This side you do a derivative. du is equal to 1 over x times dx. This side is an integral. b x to the 4th over 4. U times v minus the integral of v du. This part is equal to x to the 4th over 4 ln of x minus the integral of x to the 4th over 4 times 1 over x dx. So back to the top, this is going to equal, let's put 1/4 x to the 4 ln of x minus 1/4 of integral 1/4 multiplied by the integral of x cubed dx. This one's not too bad. We this here. Okay, x to the 4th over 4. So I thought that was going to be more interesting, but it's just there's nothing that's going to simplify. So we're going to add some number c. And maybe write this one last time. Final answer. By the way, I just made these problems up today, so if you see any mistakes or if you have any questions, just let me know. We'll stop and double check stuff. Okay, this one is from a book. So this next integral is from 0 to pi of t sine of 3t dt. I'm going to simplify the problem, and I'll just make a similar but different problem for your test. So we're going to take away the bounds because I want to make sure we talk about chapter 9. I'm also going to take away this 3. So don't need that. you want to pick u to be the value that gets simplified when you do a derivative. So we're going to have u equal t. dv will equal sine of t. Okay. U will be equal to 1 times dt. And v is negative cosine. So derivative of cosine is negative sine, and that other negative there gets you back to that positive sign. There and there. This integral is equal to u times v minus v du. Okay, so this is a negative t cosine of t plus the integral of cosine of t. So that last part is going to be a plus sine of t. Yeah, cosine of x. And then add c at the end. So with this by parts, we've been leaving off the c until you get your final answer plus c. Let's do something from chapter 9. So we're going to find the distance between 2 points. First point is, let's do 8. -1, 3. -2, 0, 4. Okay. Oh, when should we have that? By Monday. That's my goal, so that you can know what the answers are like during finals week. So yeah, I'm hoping to have exam 2 graded over the weekend. I apologize for being super behind on that. Okay. Yeah, that's cool. Thank you. Okay. Yeah. The distance formula is the square root of the difference between your x values squared added to the difference between your y values squared. Added between, let's do this, x1 plus x2 squared. Wait, the difference between these. And y values and z values. Okay, here's where I want to skim through our old notes, make sure we did the washers right, and make sure that formula is correct. And Yeah, it's cool. So let's go to distance. Yeah, as long as the subscripts are consistent, that would be the right formula. So let's put our values in there. We'll call this so side note, and I'll write it down. Goal grade. Then we're gonna do x1, y1, z1, x2, y2, z2. Put it in the formula. So it's going to be 8 minus -2. -1 minus 0. And then 3 minus 4. So simplify this. 10 squared is going to be 100 plus 1 plus 1. So I got the root of 102. And on your test, you could leave it like that. I'm just going to leave it like that. Let's do one more. It should be pretty simple. Let's go with origin and 2, 5, 7. The difference between your x value squared, add the difference between the y value squared, add the difference between the z values squared. Well, it's easy. All of those first terms inside the parentheses are going to be a 0. So 0 minus 2 squared plus a 0 minus 5 squared plus 0 minus 7 squared. Okay. -2 squared will be 4. -5 squared is going to be 25. -7 squared is 49. And that's just at least like one more step. Looks like 39 plus 40. Not a good calculator. If you got the answer though, let me know. And you take all those together. 78 for the root of 78. I'm just gonna leave it there. Cool. Next, we should find some x and y and z intercepts. So their function f of x. Oh, let's see. We're just gonna have an expression or equation. let's make this a 1. This equals 1. Okay, find the x-intercept, the y-intercept, and the z-intercept. Or some teachers might say find all intercepts, which means all 3. So x-intercept, you let y equal 0 and let z equal 0. Okay. For x plus 7 times 0 minus 3 times 0 equal to 1 means that x is going to be 1/4. Then y-intercept, we'll do here. Okay. You have z equal to 0 and x equal to 0. So 4 times 0 plus 7y minus 3 times 0 equal to 1. And that means that y is going to be 1/7. Last one. And also you can just put that as your answer. X equals, y equals, z equals. What does z equal? Okay, 0 plus 7 times 0 minus 3. 0 plus 0, negative 3z equal to 1. I've got a z equal to negative 1/3. I think that one's not too bad. Like, we could maybe just go on to a problem from 9.3. Okay, so we're going to have a function. Sorry if I'm in a rush, by the way. I just want to make sure we do a lot of examples. Oh, for the answer, would it be an ordered pair for the answer? You can do either one. I won't mark it wrong. So what you have here is a 0, 0, negative 1/3. So that's also correct. So it's the z value or the full point, either one. So like it would be like a triplet if you write it as a point. And this one's going to be 0, then your y value, then your z value is 0. So like a 0, 1/7, comma 0. I forget what that, oh, let's see. The first one would have been 1/2 for x. 0, 0, what are the other values? Y and z. Aha, cool. So yeah, you can have the actual z or the full point. This would be, that was your x-intercept. This is a y-intercept. Okay, so let me figure out some function. Let's just go fresh. Okay. We're going to have, let's make it 8 minus y squared plus 3x. It's squared. Let's go squared. Okay, fine. put in the 0.02 for your x and your y. So f of 0.2, which can be written like f of the 0.0, 2. Really, this is going to be your x, and this is going to be your y in that function. We're also going to do f of t1. So you're inputting 0 for x and 2 for y. Okay, 8 minus 4 plus 0. So f, this function f, sends 0 to an output of 4. Nothing super special, but this is a little more interesting. You're putting t in for x and 1 in for y, and just simplify what's left over, which will probably be some kind of function. F of t1. 8 minus 1 squared plus 3 times t squared is going to be 8 minus 1 plus 3t squared. So I've got 7 plus 3t squared. Just some kind of parabola. We don't have to like totally describe what's going on. You can just write that as your answer. Got 8 minutes. Are there any topics that you want an example from? Like any that you're kind of worried about, and I can go find something, make up some kind of problem? I don't know. For me, the one I'm a tiny bit worried about in general, yes, let's see. It's like partial fractions, but I've got a shout out for 6.6 disks. Cool. Okay, let's do some more like that. Okay, 6.6. Okay, I'm going to, okay, cool. And then a specific homework problem. I'm going to make this easy. Oh, wait, let me see. Are we talking about number 4 from 6.6? Yes, okay, 1 second. Let's see how this goes. Okay, let's see. It's got, let me make sure here. Oh, thank you. Please. Oh, we're not going to have traces on the exam, on the final exam, by the way. But you can ask on WebAssign about. I have to catch up on WebAssign questions, but you can ask me on WebAssign and I can help you with that problem. Let's see. Number 6.6, number 4. I've got y equal to x minus 1 and then y equal e to the x minus 2 and x equal to 1. So is that correct? Okay. Does this look right? Like the question? Oh, we got lots of messages. No, running out of time and I don't know how to use Zoom very well. Okay. Find the trace. We're not going to do traces today. I'm sorry, but you can ask me again in office hour. Okay, thank you. Yes, we'll do. Okay, cool. Find the solid from the round region bounded by the graphs and the equations by the x-axis. Well, these are the graphs and equations I have from that problem. So let's just start working on this until end of class. About the x-axis. Y equal to x minus 1. So you're going to start at negative 1 as your intercept, go up 1 over 1. And then y equal to e to an x minus 2. It's going to swoop. I think we'll use Desmos. Where did I do? Okay, here we go. So you should see my screen. We already know what y equal to x minus 1 looks like. I'm not sure about y equal to e to the x minus 2. And also we're going to have x equals 1. Ooh. So the area between these two functions rotated about the x-axis. I think you need to do this in 2 pieces. You want to have an integral from x equals 0 to, well, I'm thinking where it hits this x-axis right here, to, yikes. Where y equals e to the x minus 2 is equal to 0. And then keep on integrating from there over to x equals 1. Oof. Sorry about.
Okay, and the graph.
So this one looks kind of weird. I'm not going to be able to figure it out in just a few minutes. Sorry for assigning such a difficult problem. Let's see. We're pretty much out of time. Well, there's not going to be anything like that on your test. I want to say that overall, I will take into consideration like your efforts this semester when I make your final grades. So it doesn't have to be, it will be, plus or minus a few points, like decimal points when I do those final grades. So those little problems from homework that were like unanswered won't affect your overall score. Okay, thank you everybody. This is the last time we meet. I had a good time. I hope you have a good finals week and a good summer break. Yes. Take care. Okay. Bye everybody. You guys were awesome. Thank you so much. Yeah, I'll try.